number 29, Jimmy has a strictly increasing sequence of 4 positive whole numbers. He notices that he can create a 3-term arithmetic sequence by removing a term from the original sequence, and he can also make a 3-term geometric sequence by removing a not necessarily different term from the original sequence. Given that the first and last terms of Jimmy's original sequence are 1 and 49, how many different sequences could Jimmy have? Now, we know that one term is 1. There's 2 terms in the middle that we don't know. We know they're greater than 1 and less than 49. And our fourth and largest term is 49. So there's a few cases that we need to worry about. First, if 1 and 49 are both part of the geometric sequence, well, then finding the geometric mean of 1 and 49 is going to be the square root of 1 times 49, or just 49, which is 7. So one of these terms has to be 7. And then it follows that we have to have a fourth term such that that term either forms an arithmetic sequence with 1 and 7, 1 and 49, or 7 and 49. And we can set that up in multiple ways. First of all, if 7 goes here and it's 1 blank 7, then the change in terms is 3, and this number is 4, so there's one possibility. If 1 and 7 are part of the sequence, but 7 is the second term, then the change between terms is 6, and the second term is 13, or the third term is 13. And then if 7 and 49 are the pair, then 7 can't be the second term because then so 7 can't be the third term because then the second term would be less than 1. So it can only be the second term, and our third term is going to be 25. Or not 25, it's going to be 28. And then if 1 and 49 are both part of the arithmetic sequence as well, then the change is going to be 24, and our third term is going to be 25. So there's 4 possibilities in this case. Now let's consider the case where where both 1 and 49 are in the arithmetic sequence. Now, if they're both part of the arithmetic sequence, then one of the middle numbers has to be the arithmetic mean of 1 and 49, which is 50 divided by 2, or 25. So in this case, we know that one of these terms is 25. And then to avoid overcounting, then we need to have the final number in the sequence form a geometric sequence with either 1 and 25 or 25 and 49. It can't be 1 and 49 because then we'll end up overshooting our goal. If the sequence is formed with 1 and 25, then 25 is going to be the third term, and the next one's going to be 5. And if it's formed with 25 and 49, then the change will be 7 over 5, and the third term will be 35. So we end up with 2 possibilities in this case. And then finally, if one of 1 and 49 is part of the arithmetic sequence and the other is part of the geometric sequence, then both of our middle numbers have to be part of both sequences. If 1 is part of the geometric sequence, then let's call the change x, and we're going to have terms of 1x, x squared, and 49. But then we would need x, x squared, and 49 to form an arithmetic sequence in that order. So we'd end up needing x squared minus x to equal 49 minus x squared. And if you simplify this to a quadratic statement or a quadratic equation and then apply it to the quadratic formula, you're going to find that there's no real no whole number solutions for x. So that's not a possibility, and that means that this isn't a possibility. That would require us to have the 1 be part of the geometric sequence, or not the part of the arithmetic sequence, and the 49 to be part of the geometric sequence. Now let's call the change between terms in the arithmetic sequence x. Then this term would be 1 plus x, and this term would be 1 plus 2x. And then it would require that 1 plus x to 1 plus 2x to 49 be a geometric sequence in that order. And then we'd end up requiring that the ratio between them is the same. So 1 plus 2x over 1 plus x equals 49 over 1 plus 2x. And if we expand that to a quadratic equation as well, you'll find that that also doesn't have any whole number solutions for x. So this also doesn't work at all. So this case yields 0 additional possibilities. And our total number of possibilities is 0 plus 2 plus 4 or 6 different possible sequences.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.